Alright, so more alkanes. And the first thing you have to do when you're doing alkanes is remember find your longest chain. So take 2-3 seconds, find your longest chain. And hopefully, when you find your longest chain of carbons, you see that it goes 1, 2, 3, 4. And then you have a choice. You can either go up or kind of down and to the right. And the longest chain is up. So your longest chain of carbon is 1, 2, 3, 4, 5, 6. So that means our longest chain, if we could look up 6, is hexane. We do have 2 little things hanging off, so we want to mark those. And again, they're just 1 carbon, so it's a methyl group. And this is another methyl group. Now we have to number, and if you look here, they're equidistant from the end, and they're both methyl groups. So there's no right or wrong on this one. You can number from the top, or you can number from down here. The only thing I will tell you that this would be different is, like, say this was a methyl, and this was an ethyl. If there's no right end to number it from, then what you would go by is you fall back on alphabetical. So in that case, ethyl would come before methyl, so you would number whichever end was towards ethyl. It's a very rare occurrence, but you do need to watch out for it. So it doesn't matter in this case, so I'm just going to say that this is my number 1 carbon, which means 2, doesn't like me, 3, 4, 5, and 6. Alright, so we're going to put it all together. We have 2 methyls, which means we need to have 2 numbers. 1 methyl's on the 3, 1 methyl's on the 4. So we should have 3, 4. Since there's 2 methyls, we need to let them know that, so we have to put a di in front. If there's 3 methyls, we'd have to say tri. If there's 4 methyls, we'd have to say tetra. So 3, 4 dimethyl. And then we look at our longest chain, which was a hexane. And that is our guy right here. So 3, 4 dimethyl hexane is our full name. Next one. What I'll do is I'll pause it, try it, and then once you start the video again, the name will be there and you can see if everything looks good. Alright, so this is how I marked it all up here. Hopefully you found your longest chain was 6, again with that little hook here, because 6 carbons in a straight chain is longer than 5. So that means our longest chain is going to be hexane. I marked all my little guys right here. These are all methyl groups because they're all just 1 carbon. And then I numbered it here. You do need to number from the left and not the right, because if you notice here, more things are hanging off towards the left than they are to the right. So if I number it from the left, I get 2, 3, and 4 have things hanging off of it. If I would have numbered from the right, this would have been 3, 4, and 5. So that would have been too high. And we have to just make sure we number from there. And when you put it all together, you should get 2, 3, 4 trimethylhexane. Hopefully. Alright, same thing. I'll pause it. You can try it, and then our last one of this type is just the really big one. Alright, so same kind of thing here. Longest chain is kind of like a little U, but you should have your longest chain being a 5 thing. You could have, this could have been your number 1 carbon. It's okay. As long as your longest chain is 5 carbons, you should get the right name here. You should have 3 methyls. And you should number from the left, because that'll give you the lowest overall numbers here. So that'll give you a name of 2, 3, 4 trimethylpentane. And our last one that we're going to practice together is this guy. He's much bigger, so he's fun. But let's do him together. So luckily, his longest carbon chain is kind of very apparent. So he's right across. And then we have all sorts of different things here. So I'm going to just do them in different colors. We have a methyl here. We have a methyl here. And we have a methyl here. Now we have, for the first time, different things here. So what you'll notice here is now there's 2 carbons off together. This is what we call an... Oh, didn't switch. I apologize. That is what we call an ethyl group. And then you can see there's another ethyl group right here. So I'm just using the same color so we can kind of group them together. And we also have this guy right here, which is 3 carbons, which is an ethyl group. So I'm just going to mark those. I have a methyl, a methyl, a methyl. I have an ethyl. Oh no, that's not an ethyl, that's a propyl. Sorry, I'm messing up today. Let's try again. My ethyls are up here. Ethyl is 2 carbons. And then 3 carbons is what we call a propyl. And then we have a longest chain of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look that guy up, it should be a decane. So 2 things we have to do. We have to figure out which end should we start numbering from, and then also what orders should we put all these crazy things in. So if you look at the actual structure here, you'll see that more things are to the left. That is a typical hint that that's the end you should number from. So if we number from this end, you're going to get lower numbers overall, which is what you want. You can try it from the other end, but what you're looking for is like when you add up all the numbers, they would be lower, and you get lower numbers numbering from the left. And then the last thing we have to do is we're going to put it all together, and now we have different types. So we have methyls, ethyls, and propyl. You have to do it alphabetically on these names, not on any prefixes like di or tri or anything, on the actual names. So alphabetically, ethyl is first. So when we do our name, our full name, that's what we have to worry about first. So we look at our ethyls groups. We have a 4-ethyl and a 6-ethyl. So we're going to say that 4, 6. There's 2 of them, so we call it a diethyl. You make a comma, or you can make a dash, it doesn't matter. So we have a 4, 6 diethyl. That means they're done. Then alphabetically, the methyls come next. So we have a 2, 3, and 8. There's 3 of those methyls. So a trimethyl. And then alphabetically, the last guy is propyl. So we have a 5-propyl. And to finish all off, we just put in our longest chain, which is a decane. So your full name is 4,6-diethyl-2,3,8-trimethyl 5-propyl decane. And you sound really, really smart, and you can tell your parents and show them how awesome you are tonight, hopefully. Going backwards is very easy. So this is much easier. Drawing them is easier than naming them. What you kind of do is you just start at the end here, and it tells you your longest chain. So it says octane. So I'm just going to put 8 carbons straight across. 6, 7, 8. You can make them curly Q if you want, but the easiest thing to do is just to have 8 carbons straight across. And then what you can see here is it's going to tell you where things come off. So it says on the 2, the 4, and the 5, there's methyls. People say, should I put them above? Should I put them below? It doesn't matter as long as you show a methyl group. Oh, let me actually use something I can write with here. As long as you show a methyl coming off the 2nd carbon, the 4th carbon, and the 5th carbon, it does not matter which side you put them on. You could put them all on top, you could put them all on the bottom, you could alternate. And then it says that we also have a 3-ethyl, so I'm just going to put my ethyls together. And remember, ethyl just means 2 carbons. So, again, you could have drawn these with all of them up. You could have drawn them with some up and some down. As long as they are attached to the right carbon, you are fine. So, take a second. Again, I'll pause it for the 3-ethyl 4-methyl hexane and just make sure. All right, so here's my Answer for my hexane is 6 straight across. I have a 3 ethyl. This is my number 3 carbon, so here's my ethyl, which is 2 carbons. And on my 4 carbon, I have a methyl group. So organic naming is kind of annoying. Not kind of, it probably is annoying. But it's very good at going backwards. It's actually nicer to draw things from organic names if you name it correctly than if you have to do the opposite here. Couple of things just about alkanes just before you're done. One thing you probably want to know is if it's just a normal alkane, instead of counting all your carbons and drawing in all your hydrogens, a general rule of thumb is that however many carbons you have, so I'm going to say my carbon sub n, so whatever n is, an easy way to get your hydrogens is you take 2n plus 2. And as long as it's just a normal alkane, it's not a ring, it's not anything weird like that, it will give you the right formula. In every case of the ones we've done, you can figure out the formulas, but you don't always have to if it's just an alkane. A homologous series here is just ones that differ from what we call a structural unit. Think of it as like a little Lego. So like we have 3 carbons, and we have 4 carbons, and we have 5 carbons. And we don't really use alkanes for that much, but some things you've heard or seen. We have gasoline, which we use, asphalt, kerosene, and different candle waxes. So they are used. They're not as seen widely as some other classes of organic compounds, but it does occur.